Alright, hi class. So last time where we ended the lecture was we talked about quantum numbers. So we briefly talked about quantum numbers. And if you remember, we said there are four quantum numbers: N, L, M sub L, and M sub S. And we said essentially what these quantum numbers are, the way you can look at it, is they're an address for an electron, address for electrons. They would tell you the location of electrons. For example, if you want to find someone, you need to know their house number, the street number, the city, and the state. And if you want to find electrons, you need to know N, L, M sub L, and M sub S. Now, you also have to remember that we can never be sure where the electrons are. So the location of electron, it will always be a probability. Alright, so location of electrons, those are the quantum number, and it will always be a probability. Now what we're going to do, we are going to go over each one and see what these numbers mean. But before I do that, I want to give you an overview of these numbers. So the quantum numbers, we have n quantum number. And what n quantum number is a principal. Is a principal quantum number. I'm going to put QM for quantum. And a principal quantum number tells you the size. The next one is L quantum number. What we call that? We call that azimuthal. I'm going to try to spell that. That's azimuthal quantum number. And what that tells us the shape. The next one is M sub L. M sub L is magnetic quantum number. And that one tells us the orientation. Okay? The last one is M sub S. That is the spin quantum number. And that tells us the spin. So this is an overview. I'm going to come back to this as we go over each one in detail. But I need you to remember, it tells us where the electrons are most likely located. Tells us where the electrons are most likely located. Okay, so now let's break this down. The first thing we're going to talk about, we are going to talk about shells. So you know what those numbers are. Now, if you remember, even for the Bohr model, we said we have a nucleus, and around the nucleus, we have these orbitals. We have these energy levels around the nucleus. We have these energy levels around the nucleus. I'm going to draw 4 energy levels around the nucleus. Okay? Now, that is my n value. That is my n value. And remember, we said the n value is what? The n value is the size. So these are my n value. So these are my energy level. Remember, the first one is going to be n equal 1, the first energy level. Then n equal 2, the second energy level. N equal 3, n equal 4, and it keeps going on. These are the energy level. Now if you look at it, n plus 1 has the lowest energy level. And n equal 4 would have a higher energy level. So you have a higher energy level as you have a higher energy level as you get away from the nucleus. So this one would have the lowest energy level. As you keep going, you would have a higher energy level. Now look at it this way. If you are closer to the nucleus, your size is smaller, and your size also gets larger as you go away from the nucleus. So you come away from the nucleus, the size gets larger, and you also have a higher energy. And the one thing I want you to keep in mind, when you go farther from the nucleus, your size gets larger and larger. So what do you think? Do you think you can house more electrons or less electrons? More electrons, because you're getting larger and larger. Alright, so that, and the way that I usually tell people to look at this, think about this as an onion. Onion has the layers, right? Onion has a layer, and this is exactly the same thing. The energy levels are layered on top of each other. The energy levels are layered on top of each other. All right, so that was our shells. Now, the next thing we're going to talk about subshells. We're going to talk about subshells. We have 4 different types of subshell. We have 4 different types of subshell. We have S, P, D, and F. Now, what this is my L value. And the N value was the size. If you go back to last page, what is the L value? The L value is the shape. Now, here's the thing. Quantum numbers have to be numbers, right? Quantum numbers have to be a number. So we are going to assign a number to each one. So S is 0, P is 1, D is 2, and F is 3. Again, we're just going to assign a number because quantum numbers have to be numbers. Now, one thing I want you to remember also, that as SPDF, they're in order of increasing energy. So you would have a higher energy as you go S to F. F would have the highest energy. All right, so far so good. Now, the next thing are the orbitals. So we got the energy levels, we got the shells and subshells. Now we're going to go to orbitals. Orbitals is basically the space in which there is a high probability of finding electrons. Again, remember, we're talking about finding electrons. We said we have S, P, D, and F, right? So we have an S orbital, and put one line for S orbital. Then we have P, put 3 lines for P. Then we have D. Now put 5 lines for D. 1, 2, 3, 4, 5. And then the last one we have F. Okay, if you like pattern, how many lines do you think it gets? Yeah, 7. Let me put 7. Okay. Now, here is the thing. Now, I want to give you a non-chemistry example to kind of understand this. Let's say you're trying to find someone. Basically, you need to figure out which floor they are living in. So if you're trying to find electrons, you go, okay, which floor is the electrons living in? First floor, second floor, third floor, fourth floor. That's my N value. Then, once you go to that floor, you have to figure out which apartment on that floor you have the electron, S, P, D, or F apartment. And once you know which apartment, then you go, okay, which room are the electrons in? And these would be the rooms. So this is very simplified, but it helps. So which level, which apartment on that level, and which room the electrons are located. So the SPFDF, the way I look at it, they're like apartments. If you go to the first energy level, first floor, there is S apartment. When you go to the second energy level, now it's larger, right? It's a larger floor, so I can have S and P. If I go to the third floor, now I can have S, P, and D. I go to the fourth floor, now I have more room. There's a larger floor. I can have S, P, D, and F. Okay, so we have S orbital, P orbital, D orbital, and F orbital. The first energy level has only S orbital. Second energy level has S and P. Third one, S, P, and D. Last one, S, P, D, and F. Okay, now we know which floor. Now we're gonna go into the rooms, right? We only have one S orbital, 3 P orbital, 5 D orbital, 7 F orbitals. And what these are the M sub L. Where am I gonna write this? Okay, so these are the M sub L value. And remember, the M sub L value tells you the orientation. Okay, so far so good. But remember what we talked about. Quantum numbers have to be numbers, right? Quantum numbers have to be numbers. So we need to assign a number to each of these rooms so we can write quantum numbers. So S would be 0. The middle one would be 0 plus 1 minus 1. This would be 0 plus 1 plus 2 minus 1 minus 2. F again, find the middle. This would be the middle plus 1 plus 2 plus 3 minus 1 minus 2 and minus 3. This is my M sub L. These are the orientation. Okay, so far so good. So we got these down. Now let's talk about what is this S orbital? What is this P orbital? What is this D orbital? Because remember what we said the L value is. The L value tells you the shape, right? So let's talk about and let's show you what these things actually mean. So if we have S orbital, now we said the SPDF are the shape, right? So the S orbital, this is the shape. It is spherical. It is spherical shape. Now I have S orbital on its first energy level. I have S orbital on a second energy level. And I have S orbital on a third energy level. Because if we go back to our last page, you'll see that first every level has an S orbital, right? Every level has an S orbital. So I have S orbital in the first, second, third, fourth energy level. Now we said the energy level, the N value is the size. We said the N value is the size. So the 1S would be, let's say this is the size, the 2S would be bigger. The 3S would be bigger than that, right? And that's the shape for the S orbital. It's a little hard to write with this, but you can also look at your textbook to see what it shows for the shape. Now, the next one, let's talk about P orbital. So, the shape for the S orbital, this was the shape, spherical. P orbital is like a dumbbell. Just gets less. It's like a dumbbell. Now, remember how we just said that for S orbital, there is only one room, right? You only have one S orbital. And let's go back here for a second. Pay attention to this part for me. So we said that for S orbital, we only have one option. We have one S orbital. P, we have 3. D, we have 5. F, we have 7. Now, these were M sub L. M sub L is the orientation. M sub L is the orientation. So the S is the shape. I know the shape. The M sub L is the orientation. So now, what does that mean? If you have an S orbital, if you have this shape, how many different orientation can you have? For a circle, how many different orientation you can have? Just one. And that's why we only have one S orbital. That's why we only have one S orbital. Because there's only one possible orientation. Now, if you have a dumbbell, how many different orientation do you think you can have? The dumbbell can go this way, it could be straight, or it could be slanted the other way. So how many possible orientation you can have? 3 possible orientation. So this would be 3 possible orientation. It could be straight up, slanted to the right, slanted to the left. So 3 possible orientation. Therefore, we just said that you would have 3 of these p orbitals. The M sub L would be 0 plus 1 minus 1 because you could have 3 different orientation. And it keeps going on for D. D gets crazy. I'm not even going to try to draw it out. And F even gets crazier than that. So again, the L is a shape and then the M sub L is the orientation. Look at your textbook also to look at some of these shapes. You can look at some of these shapes. Alright, now what I'm going to do, since I didn't have enough room, I'm going to redraw this again. So we said we have an S orbital, 1 orientation. We have a p orbital, 1, 2, 3 orientation. We had a d orbital, 1, 2, 3, 4, 5. And we had an f orbital, which was 1, 2, 3, 4, 5, 6, and 7. Okay? And we said we need numbers for quantum numbers. So this would be 0, 0 plus 1 minus 1, 0 plus 1 plus 2 minus 1 minus 2, 0 plus 1 plus 2 plus 3 minus 1 minus 2 minus 3. Okay. Now what we're going to do, let's talk about electrons. I'm going to denote electrons as an arrow like this. So this is an electron. This is an electron. Now here's the thing. In each room, you can put 2 electrons max. Okay? 2 electrons max. What you can do? 2 electrons is the max you can put in each room. But what I want you to do, I want you to watch my hand. I'm in the S orbital first because that's the lowest one. I go 1, 2 electrons. I want to come over here. You can watch my hand. 1, 2, 3, 4, 5, 6. How did I do this? I put... Oh, give me 1 second. What just happened? What I do is I put 1 electron in each room. And once I need more, I go back and I double up. And that makes sense. Because there's no point of putting 2 people in the same room if there are empty rooms around. So same idea. You're going to put 1 in each one. And if you need more, you're going to go back and then you're going to double up. Okay. All right. Now, I want to ask you a question. If you are on a first energy level, what's the maximum of number of electrons you can put? If you're on a second energy level, what's the max number of electrons you can put? If you're on a third energy level, what's the max number of electrons you can put? Let's go back to our first page. So, if you have an s orbital, you can have 2 electrons. So the max in here is 2 electrons. If you go to the second level, you have S and you have P. S max 2 electron, P has max 6 electron, so together would be 8. And so on. Okay, I want to give you a second to kind of understand that. Now, I will write it again, just to make sure that everyone's on the same page. So here's our nucleus. Here's my first energy level, which only has S. My second energy level has S and P. My third energy level, for example, has S, P, and D. And my fourth energy level has S, P, D, and F, right? So, again, you only have S electrons, so the max you can put is only 2 electrons. Now here, second energy level, you have S, which you can put 2 electrons max. You have P, which you can put 6 electrons max. So 8 electron is the max you can have. Now for N equals 3, remember 2 for S, 6 for P. How many for D? Count this. 10 for D. So 2 plus 6 plus 10 is, oh boy, have to do some math. Okay, now I'll let you do it for N equals 3 and N equals 4. So what's the max here? 18. What would the max for down here? Remember, here, 2 max for S, 6 max for P, 10 max for D, and 14 max for F. So what we get is 32 max electron. Okay. Alright, that explains our quantum numbers. Now, again, remember what we talked about. We're talking about where the electrons are, right? We're talking about where the electrons are and where we can find the location of them and put the atom together. And we'll do that in 1 second. There's one more thing I need to talk about. And so we said N is the energy level, is the size, L is the shape, M sub L is the orientation. The last one was M sub S, which was the spin. Now here's the situation with the spin. If the electron is upward, we call it plus 1/2. If the electron is down, we call it minus 1/2. Again, remember, for quantum number, we need numbers. If the spin is up, plus 1/2, the spin is down, minus 1/2, because quantum number, we have to give it a number. All right. Now, let's kind of bring it home. Let's pick fluorine. What I want you to do, take out your periodic table and tell me number of electrons, number of protons, and number of neutrons for F. If you look at it, you'll see that fluorine has 9 electrons, has 9 protons, and it has 10 neutrons. So what we're going to do, this is kind of something that you would do in high school, but it's good to make sure we get the basics down. We're going to build a fluorine atom. We're going to build a fluorine atom together. So, how am I going to build this atom? I'm going to have a nucleus. And inside my nucleus, let me erase this. Inside my so I'm going to have a nucleus. Inside my nucleus, what do I have? Nucleus, I have 9 proton and I have 10 neutrons, right? Because protons and neutrons are inside the nucleus. Now, let's put the electrons together. In the first energy level, we said, how many electrons can you put? 2, right? We said in the first energy level, you can put 2 electrons. So because you only have S, so I'm going to put 1 electron, 2 electrons. Okay, so I have 9 electrons altogether. I put 2 electrons in the first energy level. I have 7 electrons left. I'm going to go to the next energy level. I'm going to put 1, 2, 3, 4, 5, 6, 7 there. And I can do that because what's the max I can put in a second level? Remember, second level, the max is 8. All I needed was the max. And point to it, the max is 8. All I really needed was 7. So here is my fluorine atom. Now, the other way to write this, a little bit fancier, would be, let's talk about energy levels. So, first energy level, on the first energy level is 1, right? And in the first energy level, I have an s orbital. So I call it 1s. First floor, my s orbital. And I'm going to put 2 electrons in there. That's what we did. We put 2 electrons in there. I need more electrons because I have 9 electrons altogether. Then I have to go to the next energy level. My next one is 2s. Second energy level is 2s. And on a second energy level, what else do I have beside s? I also have p. I also have p. Again, I'm going to go back here to make sure you guys understand this. Remember what we talked about. First energy level, I have S, then I have S and P, S, P, and D. So, here, first energy level, I put my S. Second one, I have S and P. And remember, we said P has a higher energy than S, right? What I wrote down on the side, which we can do it again, I said SPDF is increasing energy. Okay, so first I'm going to build up this one that has a lower energy. So 1, 2, 3, 4 electrons I put down. I need 9 electrons altogether. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. I put down electrons. So you have to build it up from bottom to top. That's how we would do that. I would never ask you to do this on an exam, but this is good to kind of see what these numbers mean, what we're doing here. We're building an atom. You want to know where we can find the electrons. Now, what you probably learn, and this is, you learn in high school, but now you know where those numbers are come from, this is what you probably learn. So the first level is 1, and I have an s orbital. And how many electrons do I have here? I have 2 electrons. So it's 1s2. I go to the second level. I have my s orbital. I have my 2s. So it's 2s2. Then I'll go to here. I have my 2p. So then it becomes 2p. And how many do I have? I have 1, 2, 3, 4, 5 in there. It would be 2p5. And remember this. That is, if you add up 2 plus 2 plus 5, it ends up being 9 electrons. And that's how many electrons we needed for fluorine. Yeah? Okay. So the next one we're going to do, and you can pause me so you can do this on your own, and then check your answer with me. We're going to build up a sodium atom. We're going to build up a sodium atom. Okay? The first thing you're going to do, you're going to figure out number of electrons, number of protons, and number of neutrons. Again, you can pause me, and you can do this, build a sodium atom like I did, and then check your answer. So sodium has 11 electrons, it has 11 protons, and it has 12 neutrons. We're going to go in a nucleus again. In a nucleus, it has, let me see. So in the nucleus, what I'm going to draw the nucleus. Here is the nucleus. In the nucleus, it has what? 11 proton, and it has 12 neutrons. That's my nucleus. Then I'm going to go to the first energy level. And in the first energy level, how many electrons can I put? I can put 2 electrons. Okay? I can put 2 electrons. Remember, it has 11 electrons altogether. I put 2 in the first one, so I have 9 electrons left. So I'm going to go to the next energy level. If I go to the next energy level, the max I can put remember this. When n is 2, the max I can put is 8 electrons. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. That's the max I can put. But what does that mean? What does that mean? So here's the max I can put. So if I put the max, I have 1 electron left. Where am I going to put the last electron? I have to go to the next energy level. I have to go to the next energy level, and I'm going to put 1 more electrons there, and then bam, we have taken care of our 11 electrons. So let's do this again. Let's do it in a little bit fancier way. Here are my energy levels. First level, my first level, I have an s orbital, right? And what am I going to put? There's 2 electrons in there. 1, 2. Then what I'm going to do, I'm going to go to the second energy level, second floor. I have s orbital in the second floor. Also have p orbital in the second floor. And p has a higher energy than s. So I'm going to put 2 in an s orbital. And I'm going to put 6 in a 2p orbital. If you count everything, 2 here, 4, 6, 7, 8, 9, 10, 11. I need 1 more. So I'm going to go to 3s, and then I'm going to put 1 electron there. And bam, this is what sodium would look like. Now, remember, again, what you learn in high school, it was like 1s2, 2s2 probably. But remember this, because this is what it's telling us. It's telling us how you would build an atom, what an atom looks like. So if I want to write it a fancy way, 1s2, because the first level I have s that has 2 electrons. Then I'm going to go to the second energy level, is 2s, and it has 2 electrons. So it will be 2s2. Then I'm going to go to the next one, is 2p, and I have 6 electrons. Oh my god, 1, 2, 3, 4, 5, 6 electrons. So it would be 2p6. Then I go to the next one, is 3s1. Yeah. And what we call this electron configuration. Electron configuration. That's what we call this. We call this electron configuration. We call this electron configuration. Okay. Now, here is the thing. Here's the thing though. I'm hoping I hope you feel pretty good about this so far. Here comes the exception, but it's okay. So we said the first energy level, we have an s orbital. Then we go to the second energy level, we have a 2s orbital. And on the second energy level, we also have, we also have 1, 2, 3, a 2p orbital, right? Then we go to the next energy level, and we have 3s orbital, okay? And then we also have 1, 2, 3, a 3p orbital. So the life is good. Life is really good right now. 1s, we go to the second energy level, 2s and 2p. We go to the third energy level, 3s and 3p. But you would think that after 3p, it should be 3d, but that's not the case. What comes after that, then it becomes 4s, and then it becomes 1, 2, 3, 4, 5. Then it becomes 3d. I know. And then after that, we have 4p, 1, 2, 3, 4p, and then we have 5s. So up to here, things are good. And then after that, it's not really following what we talked about. So what happens, there are crossovers. There are abnormality, there is some exception that is going on. And for example, the 4s happens to be lower energy than 3d. So you're good up to here, and after that there are crossovers, and then some of the energy levels are lower than what we expected, but you don't have to worry about this. You don't have to worry about this at all, because now what I'm going to show you is how to do the electron configuration based on a periodic table. And periodic table will take care of all these abnormalities and all these exceptions for you. But I just want you to know that there are crossovers. You would expect to be 3D after 3P, but there's 4S at a lower energy. So there are all these crossovers. But we would never really ask you to do electron configuration based on this. I want to show you how to do electron configuration based on periodic table, which take care of all these exceptions. But what I want you to get out of this, to kind of learn that electron configuration is building an atom. It tells you what an atom looks like. Okay, so I'm going to end this lecture right now, and next lecture I'm going to show you how to do electron configuration based on periodic table. So please make sure that you print out or you have a periodic table in front of you, and if you can use a periodic table that I had emailed to you and is on Canvas, that would be great. That's a great periodic table to use. Okay, I will see you guys then.